SIP9 Hub.
Hello, welcome to another episode of SIP9 Hub. This is another episode of our series on Inferential Statistics, and in this video, I'm going to present to you how to conduct hypothesis testing in MS Excel. For this presentation, we are going to conduct a hypothesis test that answers the problem that we are going to present.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Before we proceed to hypothesis testing, let us first explore the feature of MS Excel that does the hypothesis test that we want. By the way, I am using MS Excel 2016. If you are using other versions, perhaps a lower version, it's okay, because this presentation would still be applicable. In our MS Excel, to conduct a hypothesis test, we have to go to the menu Data, this menu here. And under this menu, one of the tools should be Data Analysis. That's the last part of the tools that we have here, Data Analysis. And if you could see that one, you are ready to conduct hypothesis testing here. If you do not see this button here, do not get disappointed, because it only means that data analysis in your MS Excel is not yet activated. So I'm going to show you how to activate data analysis. Just like the case here, if we click data, we cannot see any data analysis button here. It's okay. What we need to do is to go to File, and then we look for Options. So I'm going to click More, but if you have seen it already, just click Options. So here we have Options. It will give us a pop menu, and in the left part of that window, we should read add-ins. We click on that, and then at the bottom part, we click Go. Alright, so you should notice that majority of those things listed here are not checked. That's the reason why you cannot see that button Data Analysis in our main window. So what we have to do is to check these listed things here. So I'm going to check Analysis Toolpack. We also need Analysis Toolpack VBA. We also need Solver Add-in. After clicking the three of them, we click OK. And we should see that button here. Let's just wait for a moment. There. So under Data, we can already see Data Analysis here. So we are now ready to conduct a hypothesis test. Let us have the first one. Let me read first the first problem. The following are the final grades of 35 students in the subject Purposive Communication. These students were grouped according to their senior high school background. And senior high school background means that whether the student is humanities or non-humanities major. We're going to test whether this is an indication, this data here is an indication that the two groups have different average final grades. So perhaps the situation here, we have college students as our respondents. They come from the senior high school, and purposive communication is minor subject here. So normally this subject is taken by first year college students. So perhaps the researcher wants to know if their grade here, purposive communication, since it's very related to the humanities subjects that were taken by the humanities major in the senior high school, this data would perhaps indicate that students with humanities as their major in the senior high school would perform better in purposive communication. That is what we want to test. So this is a group of the non-humanities students. Before we proceed doing hypothesis testing, of course, the first question here is to identify the elements that we need. So we start with our hypothesis. The first one is our null hypothesis. We are trying to compare the means of the two groups. Our null hypothesis should be the average final grades, or we say the mean grades, of the two groups, the group of humanities students and the group of non-humanities students, are not significantly different. So this is our null hypothesis. There are other ways to state this sentence. We can say that the mean grades are equal. That's just the same. Or we can actually use symbols like this. So this symbol here, the mean grade of the humanities major is equal to the mean grade of the non-humanities majors. So we just pick one. We do not have to write the three of them since they are just the same. For our alternative hypothesis, it's just the contradiction of our null hypothesis. So if our null hypothesis is stating that the two mean grades are not significantly different, then in the alternative hypothesis, since there is no indication in the problem that we are testing at a particular side, we are testing whether one grade is less than or greater than the other. This means that our alternative hypothesis is the statement the mean grades of the two groups are significantly different. So either of the two mean grades should be lower than the other. How else can we state our alternative hypothesis? We can say that the mean grades are not, this time, not equal, or if we want to use this symbol, we would say that the mean grade for the humanities group is not equal to the mean grade of the non-humanities group. Actually, our alternative hypothesis would tell us whether to use one-tailed, that's supposed to be one-tailed, or we're going to conduct a two-tailed test. Since there is no particular direction, the alternative hypothesis is not indicating whether one mean is less than or greater than the other, then we are actually doing a two-tailed test. Suppose it's indicated in the problem, we are going to test whether the mean grade of the humanities group is greater than the mean grade of the non-humanities group. Then that's the time we are going to conduct a one-tailed test. But that's not the case here, so we're just going to conduct a two-tailed test. This is the most important part. What appropriate test would answer this problem? So, by the way, suppose that we are going to conduct a parametric test. So this data is assumed to have passed the conditions for doing a parametric test. So we are not exploring the normality of this data set. We're just going to assume it since we are only trying to show how to conduct this particular test that we're going to identify. In the previous video, we mentioned that if we are comparing two groups, and if these two groups are independent, meaning the respondents or the subjects in each group are different, then we are going to conduct t-test for two independent samples. So our samples here are independent. A student that belongs to the humanities group should belong to that group only. So the students that belong to the non-humanities group are different students. It cannot be both. So t-test for two independent samples, that's the correct hypothesis test that we should conduct here. So where is that test? Again, we go to the menu, data, and then click data analysis at the right part. So if we click that, we are actually given a list of different hypothesis tests here, but we only need t-test. So we scroll down to look for it. Where's t-test? we actually can see here a lot. There's actually 3 t-tests, but these are all different. We cannot just click any one of them. This is t-test paired, so this is not what we need. What we need is t-test for 2 samples. But there are 2 options here. We have t-test 2 samples assuming equal variances, and t-test 2 samples still, but this is assuming unequal variances. So damn, we need to choose between the 2. What should we choose? Equal variances is referring to whether the variances for each of the 2 groups here can be assumed equal or not. So we need to identify first which of the tests here should we conduct. Should we assume that the variances of the 2 groups are equal or not? There are a lot of tests that can do that. Unfortunately, the only test that is available in our data analysis test here, the list of tests that we've seen here, is the f-test for 2 sample variances. So there are a lot of tests that can test equality of variances. We have the Levens test, but we do not have, as I have said, we do not have the Levens test here. An alternative for the Levens test is the f-test 2 sample for variances. And again, we are doing this because we want to decide which t-test are we going to conduct here. So it's like a hypothesis test within a hypothesis test. This is the main hypothesis test that we are conducting. We are comparing the 2 groups, but along the process, we need to identify or to know whether we should assume that the variances of the 2 groups are equal. So to do that, we're going to conduct that f-test. So we go back, select f-test 2 sample for variances, click OK, and then it will give us a pop-up menu. It will ask us variable 1 range. This is pertaining to our first data set. Actually, any of them, but of course, let's try to be more organized. Let us select this group here, the group of humanities major. So we click on this and then drag that data set. So let me include the title, the heading, humanities group. And then we do the same for the second variable. This means that we should put the second group, the data set for the second group. So from here, let me drag on the data set. Should we check this one, labels? Yes, because remember when we dragged our data set, we included the labels at the top of the column. If we did not include this one, then we do not check this one. Let us set alpha equal to 0.05%. Again, in the previous videos, we mentioned that this is the allowable probability value. We do not want this to be high because we are making the chance of committing a type 1 error also high. The last thing to do here is to identify the output range. This means that we're going to identify which part of our space here, area here, should we want the answers to be encoded. So we do not want just anywhere here, we want it here. I want the result to be encoded here, so just click on that space here and tell MS Excel that we start at this part. So let's do that. Let's click OK. We are now ready. So this is the result of the hypothesis test that we conducted. This is not the main hypothesis test that we are doing. We are just trying to identify which t-test are we going to conduct, and we want to use f-test to sample for variances. There's a lot of things going on here, but actually we only need this value. Let me highlight this one, this probability value. So the P here means probability value. This is the probability value corresponding to the test that we just conducted. And let us round it up to 2 decimal places. The answer is 0.08. It is greater than 0.05. That is our critical value for p-values. What does it mean? Remember, we are trying the variances of the two groups, and since the probability value is 0.08, are we in the acceptance region or the rejection region? So this is actually quite high. We are in the acceptance region. And if we are in the acceptance region, we are accepting the hypothesis that the two variances here are indeed equal. So let me just write that one here. There we have it. Since the probability value is greater than 0.05, we're going to assume the equality of the variances of the two groups. This means also that the t-test that we are going to conduct to answer the problem, the mean comparison problem, we have to use t-test for two independent samples assuming equal variances. This is what we need under this step. What test should we conduct? Let us proceed to the computation. This is the computation proper. We're going to conduct that t-test for independent samples assuming equal variances. So we go back to data analysis. We're going to select t-test to sample assuming equal variances there. Click OK. And actually, it's the same thing that we did a while back. We need to input the correct data sets. So for the first data set, we're going to click this part here. So hold and drag. For the second data set, hold and drag. Since I included the labels, I'm going to click labels. Let us set alpha equal to 0.05. So by default, it's 0.05. Let us specify where we want to put our results so that it would not mess our area here. I want to put it here at this green part, so click there, and then okay. Again, it will give us a lot of numbers, but actually what we only need here are a few things. We need what? We need first the mean. So looking at the mean, it seems that one group has a different mean. Let us round it up to 2 decimal places. Again, we can do that here. So we want to decrease or increase the number of decimal places. What else do we need here? What is t-stat? Remember in the last video, we presented the t-statistic that we need. It's actually this value. So we need this one. This is the p-value, but there are two p-values. P-value for a one-tailed test and p-value for a two-tailed test. Now, since we are conducting a two-tailed test, then we should select this value there. Let us round these numbers. The critical value is the same critical value that we mentioned in the previous videos, but we do not need those ones since we are using the p-values. So this is the result of the test that we conducted. Now, how do we conclude? What does this test mean with respect to the problem that we have here? Again, our probability value is quite high. Actually, it's greater than 0.05. So should we accept the null hypothesis or should we reject it? Since it's quite high, we should accept it. So our conclusion is that the null hypothesis is true. We accept it. What is the null hypothesis saying? That the mean of the two groups are not significantly different, or that the two groups have equal means. In research, we do not actually present everything that we conducted here. This is the process of hypothesis testing, but it doesn't mean that everything here should be reported. In fact, I have prepared here a table that would guide us which part of the test should we report. So this is actually a table following the BSU format. This is what we use. We only need to report the means. If we have a descriptive equivalence for the mean grades, then we need to put that. And then we need the t-value or computed. This is the same value as our t-stat. And then our probability value, which was provided by the test that we conducted. So let us complete this table. So first that we need to input is the mean, 1.88 for the humanities group. So this is actually the advantage of including the labels in the hypothesis test that we conducted, because it would guide us which is which. If we did not do that, we cannot see this label here, and we might get confused as to which means are these for. For humanities group, the mean is 1.88. We can just encode it. For the second one, it's 1.92. Or I don't want to encode it. Let me use the formula equal sign. So equals this group, this cell, equals this cell, enter, equals this cell, enter. And then, can we see the overall mean? I don't think it's provided in the test, so we can actually compute this. So how do we compute the overall mean? This means that the mean of the entire data set, we are not grouping it, but we are treating it as a single data set. So we have equals average, and then we go back to our data set and then include everything. So there we have it, enter. This is the overall mean grade. What else do we need to do? We need to give the descriptions. Remember, in the past videos that I have presented a technique so that we could automatically give the descriptive equivalence of the following means using the scales at the bottom of the table. So that is by using the lookup function. We start with our equal sign, lookup, that value that we want to give equivalent to, comma, and then the range of data that we want MSEXCEL to interpret these means here. So again, we need to put dollar signs here so that it will not adjust, and then enter. So there we have it. All the three means here are interpreted as satisfactory. The next is to input our value for t computed. That is the same as I have mentioned a while back, it's t-stat. So there we have it. I don't want that negative. Since we are doing a two-tailed test, it doesn't really matter. So let's get the absolute value. So absolute value of that cell. This is the command for absolute value, ABS. Enter. So we have 0.27. Still, it's positive because we just took the absolute value. And then for the probability value, we have which value? We have this value. So it's 0.79. So actually, this is what we need to present in our papers when we are doing a research. This is what we interpret, but not just yet. We are not yet done. We have some things to put here, some conventions that we do. Since the mean groups are not significantly different, so the keyword here is not significant. The result is not significant. We normally put something beside this number. So since it's not significant, we actually write NS. So there, we can do it this way. Anyway, I removed the formula here. I copied manually 0.27 because I cannot put NS, the letters N and S here. So that's okay. So the result is NS, and then we can put in our legend the meaning of NS. NS means not significant. And what does it actually mean? It means that with respect to the problem that we have, since the two means are not significantly different, they are just the same, regardless of the differences here that we see, because obviously, based on our data, on our samples, the two groups are not the same. In fact, they have different means. The mean for the humanities group is 1.88. The mean for the non-humanities group is 1.92. in Benguet State University, this mean would mean that humanities group has a higher mean grade. But remember that we want to talk about the population, and this is just a sample. That's why we conducted the test. And from that, it resulted to the non-significance of the two groups. That is why, despite the mean difference that we see here, this difference here, we still say that the mean grades for the two groups that we are comparing, the group of humanities students and the group of non-humanities students, their mean grades are still to be considered equal. So that regardless of the senior high school background of the students, their performance in purposive communication is simply the same. For comparison purposes, let us answer the same problem, but we have a different set of data. So this data here is different with this one, but it's the same problem. So we start with our null hypothesis. It's actually the same since it's the same problem. It's still a two-tailed test, so let's just copy that one. We want to identify which t-test should we use. Is it t-test for independent samples assuming equal variances or not assuming equal variances? So let us conduct f-test. Let us get that test. So f-test, 2 sample for variances. Let us change this data set. So where's that data set? The first data set is here. Another one here. We check labels because we included it. We want our answers here. So okay. Now what do we need here? We only need the p-value. Where's that? It's here. And what is the value? It is actually 0.01. It is less than 0.05. What does it mean? If in the first case, in the first example, our p-value for the f-test is 0.08 and that is greater than 0.05. In this case, it is not. It is less than 0.05. This means that the variances are significantly different. The term significantly different is just synonymous to saying that they are not equal. Since the variances are not equal, then we use t-test for 2 independent samples assuming unequal variances. Okay, let us proceed to our computation. So we go back to this menu, data analysis. We want to use t-test for this time, t-test 2 samples assuming unequal variances. Okay, our next job is to put our data sets, second data set, labels, specify our output range. I want it here. Okay. Again, in this test, in this t-test, we only need a few things. What are those? We want the mean. Let us organize by rounding it up to 2 decimal places. We also want this and the p-value for a two-tailed test. Okay. Now, what is the result? Our p-value is 0.02. 0.02 is less than 0.05. If we imagine that normal curve that we use to illustrate the acceptance region and the critical region or the rejection region, if 0.05 is the boundary, that's the boundary that separates the acceptance and the rejection region, then obviously 0.02 is lower than 0.05. So it is found at the rejection region. This means that we are rejecting the null hypothesis. If we are rejecting the null hypothesis, then we need to have our alternative hypothesis as the true statement. So our conclusion is that the alternative hypothesis is true. And what is that alternative hypothesis saying? That the mean grades of the two groups are significantly different. So that's the result of the test. Let us again complete our table. So what is the mean for the humanities group? We have this result. For the other one, this result is exactly 2. And for the overall, we can compute it here. And then for the descriptive equivalence, let us do it quickly. For our T computed, it is this value. Absolute value is 2.43 positive. The p-value is this value. Alright, our table is complete. What does it mean? If this is the result, if this is our data, and if this is the result of our test, how do we answer the problem? What does it imply with respect to our problem? Since from the test, it is saying that the means are significantly different, then it means that one group is performing lower than the other group. And how do we know which group is doing that? We can actually base it from the mean. It is consistent that the mean grade of one of the groups is quite low relative to the mean of the other one. Oops, we made an error here. It should not be like this. In BSU, it should be the reverse. So 1 to 1.39 should be the outstanding grade, not the other way around. So actually, we made the same error here. Let me quickly change it. I'm sorry for the error. Alright, there we have it. It should be like this. 1 to 1.39 should be the highest grade. We do the same for the second table. And since we use the formula, it will automatically adjust. I mean, our answers here. So let's go back to the problem. The group of non-humanities students has a mean grade of 2, which is descriptively equivalent to satisfactory. The mean grade for the humanities students is quite higher than this group. That's why its descriptive equivalent is very satisfactory. That's why the test indicated that the means for the two groups are significantly different because it is really different. Now, what should we put here since our result is significant? We actually put a single asterisk. That single asterisk, by convention, this is a convention in research or in statistics, this means that it is significant. The groups that we are comparing are significantly different at 5% level. Suppose our p-value here is lower, for example 0.001, it is lower than 0.01, then we do not put a single star but a double star. And in our labels, we say that that double star would mean highly significant. So the chance of committing a type 1 error is just 1%. But since our p-value is just 0.02, it's in between 0.05 and 0.01, then this is just significant. This term suggests that the chance of committing a type 1 error is at 5% still. Okay, this is the first test that we can apply, a test that is available in MS Excel. For the other test, I will see you in the next video.